Hello everyone, I welcome you to this session on problem solving on KCL and KVL. So in this video series we're going to solve few previous year questions on KCL KVL. So mainly we'll focus on gate problems or otherwise some other previous year questions or some other exam which are similar to this. Alright, so let's start. And before that, if you're not comfortable with KCL KVL, with what I'm solving, you can always look back to the lectures on KCL KVL and come back here. Okay, or else you can use my theory lectures or something else which you're comfortable with. Everything is fine, but if you are able to understand, it's well and good. That's a motive. So by solving this or by watching this video series or solving on your own while watching, it will be helpful for you to be comfortable to do some KCL KVL problems which are asked in the exam comfortably. So that's what is the motive of this video series. Alright, so let's start. So here we got two meshes and mainly one node. So I'm going to use KCL. So there's less number of nodes, we prefer KCL. So KCL is nodal analysis and KVL is like mesh analysis. So I'm going to use KCL here for this particular problem. I'm going to call this as node B and I'm going to assume the current directions. So this is going to from the left to the right to the up, and the other one is going down, going from left to right. Okay, this is my assumption. You can change your assumptions of directions as you wish, but only one thing we have to remember is that the sum of the entering current will be equal to the sum of the leaving current at a particular node. This is our node B, where there are two entering currents, this one and this one. There's one leaving current, or else I can mark this leaving current in pink, so that you can say sum of these greens equals sum of these pink. Okay, it's pink, it's fine. Alright, so let me write the equation for this. So for this current which is here flowing through the R1, the current flowing through R1 will be the voltage drop across R1 divided by the resistance of R1. So voltage drop across R1 is what? It's a potential difference or the difference of the potential, the two ends of R1. So one end of R1 is having 60 volts directly connected and the 60 volts is directly connected to the ground. So I can say the 60 volts is the effective potential at this point, because 60 volts connected directly to the ground. The effective potential at this point or the one end of the R1 is 60 volts. So 60 minus the other end of the R1 is connected to V divided by the resistance is 5 ohm. Then plus, because there are two entering currents, plus 0.04 Vx equal to the current leaving current. So V minus what? If I'm considering 3 ohms, V minus the potential at this end. The other end of the 3 ohms is this. You consider 5 ohms, this potential minus 0. Why 0? Because it's ground, completely ground. All this will have the same potential. Okay, 0, 0, 0, everywhere 0. So this is also 0. This potential minus 0 divided by 5. If I'm considering 5 ohm. But if I'm going to introduce another variable V1 or something here, it's going to be like 3 variables. Already have V and Vx. If I introduce another one's 3 variables, I'm not pretty comfortable with it. So what I'm going to do is I'm going to consider 3 ohm and 5 ohm as are in series. So the series equivalent will be 8 ohms. So V minus 0, I'm going to say, I'm going to tilt the ground part, divide by 8. Or you can understand this other way also, I tell you. So the current through 3 ohm and 5 ohm are same. So I'm coming till here. So the V minus 0. So total effective resistance from V to 0 is what? 8 ohms. So V minus 0 by 8. Okay, now I've got one equation. So to eliminate this Vx, so I need to find what is Vx. What is Vx? Vx is the drop across 5 ohm resistor. Whenever you have dependent sources, it could be a voltage source or a current source, the variable present in the dependent source will be found elsewhere in the circuit. In this case, Vx is found across 5 ohm. Okay, it's a drop across 5 ohm resistor. So what is a drop across 5 ohm resistor? It's a potential difference across these 2 points, or we can say V equal to IR. So what is the current flowing? I call that current to be I, and the resistance is 5 ohm. So this is Vx. So what I can say, this I is the current flowing through 3 ohm or flowing through 5 ohm, or the same I is flowing through the effective 8 ohm also. So I can say the current here is V by 8, right? V minus 0 divided by 8, the same current here. So 3 ohm is also the same, 5 ohm is also the same current is flowing, and the equivalent effective resistance 8 ohm. 8 ohm is also the same current I is flowing. So I can say Vx is equal to V divided by 8 into 5. Okay, I hope you see this. Okay, Vx equal to this. So we got this. Okay, so after we get this, we are supposed to substitute it to this equation, and simplify it back. Okay, let me do this. So 60, okay, let me do this 60. I can also do it parallelly because I'm doing very slow. 60 minus v divided by 5 plus 0.04 into dx is into v by 8 into 5 equal to v by 8. So I'm going to take LCM as 40 and cut all the 40. So if it's multiply 40 with this, it becomes 60 minus v into 8 plus 0.04 into v into 25 equal to v into 5. So on further simplifying this, we get 480. 60 into 8 is 480 minus 8v plus 0.04 into 25. It's going to be totally 1 volts, or sorry, 1v. This is v, so 1v equal to 5v. This is v. V is the variable we assumed here. So now when you simplify it further, 480 will be equal to 12v. So your v will be 480 divided by 12. So this is your 480 divided by 12 is 40 volts. So we got what is V. So when you got what is V, can you say what is the current I? What is I? This is the current I, right? So this is the current which this is the current which we were interested in finding, right? This current is the current that we called as I, and so that I will be equal to V by 8. So this current is V by 8 is 40 by 8. So what is 40 by 8? This is 5. So 5 amps is the current that is flowing through total 8 ohms. The total 8 ohms and 3 ohms and 5 ohms, everything is the same current. So current through your 3 ohm resistor is 5 amperes. Alright, this is the current. Because the current through current through 3 ohm and the current through 5 ohm is same. If the series combination of 3 ohm and 5 ohm will be 8 ohm. So that is also the same current will be flowing, because series combination current will not change. So 40 by 8. So 5 amps is the current flowing through this 3 ohm resistor. The same current will be flowing through 5 ohm as well. Same current will be flowing through the equivalent 8 ohm as well. Okay. So 5 amps is the answer for this problem. Thank you.